So if you have question, maybe I have some answer, not sure. But, yes, Benoit. Benoit has a question.
I have a question. In fact, it's not a question, but more a suggestion for people that are not familiar with SDR.
SDR.
Yeah. Could you remind us what are the key displays in HDHDR?
Mm-hmm.
Because
Sure.
I am not familiar with this software, and sometimes I forgot that there is a loop and a global overview of the spectrum.
Let me put just a little bit more gain. So, in fact, you have first what we call a three-dimensional display. This is frequency. So here the frequency is increasing. So basically, I have a window which is open from 77,650 somehow up to 77,830. So I'm observing the spectrum between those two boundaries. Okay? And in this window, so that's the frequency. I'm having the time also, which is rolling. So this is past and this is present. The present, the past. The more I'm going over there, the more it is a long time ago, if I can say. And the color is the intensity of what is received. And in this display, the spectrum is scrutinized in very small bandwidth. Basically, it's what we call the resolution bandwidth. So each point, which is there or there, is being created within a kind of channel of 5.9 Hertz. I can reduce it, so I can increase the resolution, which gives me more sensitivity, there is less noise, or I can decrease the resolution, which means increasing the bandwidth, which gives more noise. Okay? But anyway, it's a way of observing the energies which are within the spectrum. There is no notion of demodulation. There is no notion of listening to something. This panel is just used to look at what is present in the spectrum. Are there energy or not? For instance, we see that there is something which is present, transmitting continuously, and which is not a natural stuff. It's something which is artificial, the way it is transmitted. And we have some spurious, probably, or some parasitic transmission over there, which are very narrow. This one is probably much less narrow. Okay? Now, those displays there are more the demodulation capability. So you say, I want to know what's happening here. You position this sliding channel, and you say, I'm software tuning here. Okay? By putting your software demodulator, which is materialized by the light blue window, which is narrower than the spectrum, which can be also, if we use this kind of demodulator, which can be, and you see some effect of the modulation, which can be increased or decreased. Basically, you can tune where you observe, where you magnify the signal. Okay? And also, within this magnifying window, you can obtain certain type of demodulation. It would be an FM transmission. And by the way, we can do it. If I'm going to, let's say, 103.1 megahertz, okay, I'm observing some kind of wideband signal within the spectrum, and I have to take a decision. Okay, I'm seeing energy, but what is it? So, choosing the parameter of this blue window, so basically increasing the bandwidth of it, No, not this one. Sorry. So first, because I know it's FM, choosing FM demodulator and increasing the bandwidth, I can decide to focus on this signal, okay? And then probably I have a process of this signal which might give something. Let's try to see if it gives something. Yes, it gives something. So this is, okay. On this panel, you have all the demodulation capabilities. This is just observation of the spectrum, and this is demodulation capability. Indeed, if I'm using the wrong demodulator, let's say I'm using this one, well, what I'm hearing is not very nice. Okay. If I'm using an AM demodulator, well, I hear about potentially music, but it's not clean. I need to have the proper right demodulator to do that. And there are a lot of, indeed, trimmings, and but I'm not going to enter in those details. Okay?
Okay. Yes, of course.
You did a great analogy between the free space loss and the bubble gum. I really like the way you expressed the less energy you have, the farther you are. How can you make an analogy for the relationship of, well, the impact of the wavelength on the free space loss? The higher the frequency, the higher the path loss.
It's related, in fact, to the efficiency of the antenna. So you remember, I've been talking about the equivalent surface of captation of the antenna. Sometimes you also relate to the efficient length also. So you talk about length when you are considering capturing, for instance, the electrical field. And you are considering surface when you refer to capturing the flux of electromagnetic wave. Anyway, not entering into too much detail. In fact, this efficiency of capturing effect of an antenna depends on the dimension of the antenna. No miracle. The biggest is still trying to resonate. You always need to resonate, but it's not mandatory to resonate in half wave. You can also resonate on multiple of half wave. And you can resonate in multiple of half waves in two dimensions, not only a wire. You can use a surface. If you use a patch, it's a big dimensional antenna. And if you use a big patch or multiple patch, you really see this notion of surface. Okay? But in fact, the surface is, because of the resonance, related to the wavelengths. So the biggest the wavelengths, the biggest will be the efficiency on for a given dimension on the efficient surface of the antenna. So the more you go to and for this, you know, well, in fact, to really have the scientific explanation of that, or at least the mathematical model, we would need to go back to the Maxwell equation. But intuitively, it's a matter of saying that the more you are using small wavelengths, the more it is difficult to increase the dimension, the efficient dimension of your antenna. For instance, you might have a very small antenna, which is an electric antenna connected to a high impedance receiver. If you are working at low frequency, and this is not really intuitive, but in fact, for a given dimension, it will be much more efficient on long wave than short waves.
Thank you. I think that Aurélie has a question.
I was wondering, with your experience, what are the most common mistakes you can hear or you've seen from people who are not expert in radio?
Well, definitely, first considering that the range is a given. So the range is a fixed number. This walkie-talkie is ranging at 4 kilometers. That's the contract. No. This walkie-talkie is probably ranging, depending on the condition, between 100 meters and 200 kilometers. So that's the first mistake. People believing that the range is a contractual number. It's not. And once again, it's not a matter of range. You have to look at the budget link. And people not considering the budget link, that's also a mistake. That's a fundamental notion that you need to know if you make radio. If you don't know it, you are in bad shape. Indeed, the other big mistake is considering that we've said that the budget link was, for Sigfox, was 156. So it's 156. No, because the real budget link is 156 from an electrical or from a technology standpoint, power, sensitivity. But if you have a very bad antenna, remember the realistic, the on-the-field budget link is power, sensitivity, and antenna gain. If the antenna gains Rx and Tx are positive, good. You've increased your dry budget link. But if they are largely negative, if your device antenna is very bad, if the Sigfox antenna base station is bad, but I guess it's good because that's our job. But mainly, if the antenna gain is really bad on the device because the device is not well tuned, so basically the antenna is not working. It's radiating only a small portion of the electrical energy which has been injected in the antenna. Your budget link is not going to be 156. And it can be 100 and nothing. We've seen some device in the past that had minus 50 dB of gain. Minus 50 because that was not antenna, that was piece of crap. So in fact, the budget link was 106. Basically, it was the budget link of a Zigbee device, not a Sigfox device. So that's one of the biggest mistakes you see at the customers.
Great. Another question?
Regarding antenna on device side, is there an interest to go over quarter wave or half wave antenna?
Yes, it's a good question, and the answer can be complex. In fact, there are multiple answers. But to simplify, let's say that it's easier to have a good, well-working half-wave antenna than a good working quarter-wave antenna. Because in fact, a quarter-wave antenna, we've not been making an experiment, but I could have shown you that putting a piece of wire over there, so to say, creating one quarter wave and a second quarter wave, the radiation would have been a little bit better. Because it's always easier to have a good half wave than a good quarter wave. I'm not saying the quarter wave is not working. I'm saying that to work in the right condition, it's a little bit more difficult. So indeed, once again, the longer is the antenna, the better it is. If it is properly tuned, so if you guarantee that it's still resonant and it's still well matched to the transmitter, because you have good resonant antenna that do not present, for instance, the famous 50 ohms. They are presenting 100 ohm or 200 ohms. So you still need, although your antenna is vibrating correctly, so potentially for sure nicely radiating, you still need to electrically match it to the transmitter that most probably is going to be 50 ohm. So there are a lot of things to do. Now, remember that if your antenna is too long, and by too long saying that if it has too much gain, you are not going with a 25 milliwatt electrical power injected in the antenna. If your antenna is too good, so having too much gain, you won't pass for the ISM band, you won't pass the type approval because it's too much. However, you could use the RSABO antenna for Sigfox with a power that would be somehow minus 75 dB lower than the 25 milliwatts. Because injecting basically 14 dBm minus 75 dB of the gain of the antenna, you would be type approvable. Meaning that you would have a transmitter at extra low power, potentially.
Yeah, so it means having a very efficient antenna could lead to
Yes.
reduce the power.
Yes.
consumption of the device.
If you use a paraboloid antenna having a gain of 25, 30 dB at 800 megahertz, for sure, you need to reduce the power because to be type approved, you need to radiate a maximum of 25 milliwatt equivalent in the best direction of the antenna. But to produce that, you need to reduce their power by 30 dB. So basically, instead of having 25 milliwatt, so to say 14 dBm, you need to go down to minus 16 dBm, which is 400 microwatt. And for sure, you are going to consume much less. So if you can pay this luxury to beam on a Sigfox base station, it's much better.